A fiery streak from a distant star, or just a trick of the light? On October 7, 2025, the European Space Agency drops its first image of an interstellar comet, and the world ignites with controversy. While official channels offer blurry photos and technical excuses, NASA and other global agencies go completely silent. Amateur astronomers, however, start releasing sharper images from their own backyards, fueling speculation and outrage. What are we not being told? Let's explore this together.
The blurry dot.
It was meant to be a historic reveal, but it ended up a global meme. At precisely 9:22 UTC on October 7, 2025, the European Space Agency's ExoMars Trace Gas Orbiter released its first official images of the interstellar comet 3I, Atlas. The public, primed for a stunning portrait of a visitor from another star system, received something vastly different. A faint, blurry dot, barely visible against the digital noise of deep space. The image, captured by the orbiter's color and stereo surface imaging system, or CASIS, was immediately distributed across social media, but anticipation quickly soured into confusion and disappointment. Within a few hours, hashtags like fuzzy dot and where the pics were trending in multiple languages. This wasn't just a low-quality picture, it felt like an anti-climax to a highly anticipated celestial event. The world tuned in for a cosmic marvel and was shown a smudge. For many, this raised immediate questions. As Dr. Frank Marchus, a senior planetary astronomer at the SETI Institute noted, the public has grown to expect crystal-clear imagery from our space missions, making the blurry photo feel like a deliberate withholding of the real view.
Global outrage.
That blurry dot didn't just disappoint, it sparked a wave of digital fury. The initial letdown quickly escalated into genuine outrage as armchair analysts and amateur astronomers launched their own inquiries. Social media platforms were flooded with side-by-side comparisons, pitting the fuzzy official image against captures from backyard telescopes that appeared to show significantly more detail. The comment sections on agency posts turned into forums for accusations, with many users convinced that ESA was hiding something profound. This anger was magnified by the coordinated silence from other spacefaring nations. NASA, China's National Space Administration, and the UAE Space Agency, all operating orbiters around Mars, released nothing. No images, no press releases, no confirmations of their own observations. This collective silence felt deeply suspicious. People began to question why three independent, highly advanced space programs would all fail to get a clear shot. As astrophysicist Dr. Jesse Christensen of the NASA Exoplanet Science Institute often explains, maintaining public trust is paramount in science, and transparency is key. Every unanswered question only intensified the pressure, transforming a scientific observation into a full-blown public relations crisis.
Technical limits.
Was this a grand conspiracy or simply the hard limits of physics? Let me explain what was happening on the ExoMars orbiter. The CASIS camera was never intended to be an interstellar comet tracker. Its primary mission is to create detailed color maps of the Martian surface, identifying geological features like landslides and seasonal frost changes. Aiming it at a dim object 30 million kilometers away stretched its capabilities to the absolute maximum. Nicholas Thomas, the camera's principal investigator from the University of Bern, described the effort as a very challenging observation, emphasizing that the comet was at least 10,000 times fainter than the Martian landscapes CASIS was built to photograph. At that vast distance, a single pixel from the CASIS sensor covers a massive 340 square kilometers. The comet's nucleus, thought to be only a few dozen kilometers across, was far too small to be resolved. It was, in technical terms, a sub-pixel target. No amount of perfect focus or long exposure could turn it into anything more than a smear of light on the sensor. The resulting fuzzy dot wasn't a cover-up, it was the unyielding reality of the hardware's design.
High-rise goes dark.
Just as the world needed its most powerful eye on Mars, the camera went dark. NASA's Mars Reconnaissance Orbiter is equipped with the High-Resolution Imaging Science Experiment, better known as HiRISE. This is a formidable telescopic camera, capable of spotting rovers and even their tire tracks on the Martian surface from orbit. It represented the best chance for humanity to get a clear, detailed image of 3I/Atlas's core. But as the comet made its closest pass by Mars, HiRISE was effectively out of commission. The reason was a US government shutdown that began on October 1, 2025, which froze the majority of NASA's day-to-day operations. All non-essential activities, including the uplinking of new commands to spacecraft and the public release of data, came to a halt. Astronomers, including the HiRISE camera's principal investigator, Dr. Alfred McEwen, could only watch the empty public archives, waiting for data that would never appear. The shutdown severed the command chain, freezing the entire data pipeline. HiRISE's forced inaction created a crucial information vacuum, leaving the narrative to be shaped by blurry images and a growing cloud of suspicion.
Radio silence.
The silence wasn't just a NASA problem, it was a global phenomenon. With the HiRISE camera offline, attention shifted to the other advanced orbiters circling Mars. China's Tianwen-1 and the United Arab Emirates HOPE mission had both been tracking the comet's approach for weeks. These missions are equipped with sophisticated imaging instruments and represent the expanding international presence at the Red Planet. Yet, during the critical flyby window, both the China National Space Administration and the UAE Space Agency remained completely quiet. Not a single image was released. No official statements were made, not even a simple denial of an observation attempt. This radio silence from two other continents was perplexing. The US shutdown explained NASA's situation, but it didn't account for the lack of information from China and the UAE. As Dr. Brian Whedon, a space policy expert at the Secure World Foundation, has noted, international data-sharing agreements can be complex and are not always immediate. In the absence of any official word, speculation filled the void, deepening the mystery and fueling theories of a coordinated cover-up.
The image wars.
While the professional agencies remained silent, the amateur astronomy community took center stage, and the internet became a battleground of images. In the days after ESA's underwhelming release, a torrent of pictures from backyard astronomers around the world began to circulate online. Using advanced techniques like stacking dozens of long exposure frames and applying AI-powered upscaling filters, these dedicated hobbyists produced images that seemed to reveal stunning details. One group, championed by popular online comet hunters, claimed to see a sharp nucleus and even faint jets of gas, arguing that their ground-based setups had outperformed billion-dollar orbital missions. However, professional astronomers, including Dr. Quanji Ye from the University of Maryland, urged extreme caution. They countered by showing how aggressive digital processing can create convincing illusions. They explained that astronomical techniques like deconvolution, when pushed too far, can easily amplify background noise, turning random digital artifacts into what look like real structures. The debate quickly became highly technical, but the fundamental issue, as the professionals pointed out, was the inescapable limit of optical resolution.
Perseverance streak.
Could a rover on the ground succeed where the orbiters had failed? On October 7, 2025, a skeleton crew at NASA's Jet Propulsion Laboratory decided to find out. Despite the government shutdown, essential mission personnel were still on duty and authorized a special observation sequence for the Perseverance rover. They commanded its navigation camera, or NavCam, to take a series of exposures of the sky over Jezero crater, hoping to catch a trace of 3I/Atlas. The raw images revealed a single faint streak of light, just over a pixel in width, stretching diagonally across the frame. Its timing and position were a perfect match for the comet's predicted path. The science team, including veteran imaging specialists like Dr. Justin Mackey, began to analyze the physics. The streak's length was consistent with the motion blur expected from an object moving at the comet's staggering speed of 90 kilometers per second. It was an electrifying piece of evidence from the Martian surface, but a critical piece of information was missing: the full FITS data headers, which contained the precise exposure timing. Locked away due to the shutdown, this missing detail meant the observation remained a tantalizing but unconfirmed clue.
Wow signal link.
Just when the story seemed like it couldn't get any more bizarre, it intersected with one of the greatest mysteries in the history of astronomy. As scientists plotted the precise trajectory of 3I/Atlas, they uncovered a jaw-dropping coincidence. A line drawn from Perseverance rover's location in Jezero crater through the comet on October 7th pointed almost directly to a region of the sky in the constellation Sagittarius. This patch of sky is famous for being the origin point of the WOW signal. Back in 1977, astronomer Jerry Ayman detected an incredibly powerful, 72-second radio burst from this exact direction, a signal that has never been explained or heard again. The comet's alignment with this historic anomaly was just too perfect for the internet to ignore. Yet, despite the incredible coincidence, no major radio observatory, including the SETI Institute's Allen Telescope Array, under the guidance of senior astronomer Dr. Seth Shostak, announced a dedicated listening campaign on the 1420 MHz frequency of the original signal. The optical silence was now compounded by a profound radio silence, raising an unsettling question. With the geometry perfectly aligned, why did no one seem to be listening?
Approaching perihelion.
Every comet that ventures into the inner solar system must face a trial by fire. On October 29, 2025, 3I Atlas will reach perihelion, its closest point to the Sun. As it swings around our star, it will disappear from our view, lost in the Sun's intense glare. For nearly 48 hours, no Earth-based telescope will be able to safely track it. This impending observational blackout is becoming a fertile ground for speculation. Cometary experts like Dr. Casey Liss of Johns Hopkins University's Applied Physics Laboratory note that this will be a period of extreme stress, where comets can violently disintegrate or experience massive outbursts. But others are wondering if the blackout could be hiding something engineered, a deliberate course correction. The Galileo Project, a Harvard-based team led by Dr. Avi Loeb dedicated to searching for signs of extraterrestrial technology, has announced it will be monitoring all available channels for any anomalies as the object re-emerges. The world can only wait and wonder. When 3I Atlas comes back into view, its brightness, trajectory, and physical state will provide the next crucial set of clues to its true nature.
The November tests.
As 3I Atlas rounds the Sun and is expected to re-emerge into view in early November 2025, a global campaign of intense scientific scrutiny is set to kick off. Astronomers will then focus on a critical checklist of tests to determine what might have happened during its solar passage. First, they will meticulously analyze its light curve, the graph of its brightness over time, searching for any sudden surges or steep drop-offs that would signal it has broken apart. Second, they will use the new data to run hyper-precise orbital models, looking for any tiny, unexplained deviations from its predicted path. Such a change could be evidence of natural outgassing jets, or, as some are still theorizing, something far stranger. Hopes for an even better look are resting with ESA's Jupiter Icy Moons Explorer spacecraft, known as JWST. Though it is on its long journey to Jupiter, it has a unique vantage point and a scheduled observation window. However, as confirmed by JWST project scientist Dr. Olivier Wittas, the vast distance means that any data it collects won't reach Earth until deep into 2026. Until then, every new measurement from Earth will be another clue in a puzzle that has captivated the world. So, what are we to make of the interstellar comet 3I Atlas? The story began with a single blurry dot and exploded into a global mystery, a perfect storm of technical limitations, inconvenient political timing, and humanity's profound hope of finding something truly extraordinary in the cosmos. While the official narrative points to the hard limits of our technology, the deafening silence from multiple space agencies, combined with tantalizing clues from the Martian surface, and a spooky alignment with an old cosmic mystery, has left the door wide open for speculation. As we continue to wait for more data, the saga of 3I Atlas stands as a powerful testament to how much we have yet to learn about our universe, and how quickly a single unexplained event can ignite the imagination of the entire planet. Don't forget to like, subscribe, and hit the bell icon. Thanks for watching Space Facts. Imagine discovering a cosmic time capsule from the ancient galaxy, older than our entire solar system. On July 1, 2025, astronomers spotted something extraordinary racing through space at an incredible 137,000 miles per hour. This wasn't just any ordinary visitor, it was 3I Atlas, the third confirmed interstellar object ever detected, carrying secrets from a part of the galaxy we've never seen before. Discovery of 3I Atlas. What if I told you that finding an interstellar visitor requires watching the entire sky every single night? That's exactly what happened when the Atlas Survey Telescope in Rio Hurtado, Chile, made astronomical history. On July 1, 2025, this powerful sky scanner detected a faint moving object with the temporary designation A11PL3Z. Initially appearing as just a magnitude 18 point of light, the object was traveling through the border regions of constellations Serpens Cauda and Sagittarius. What made astronomers immediately suspicious was its peculiar motion, moving far too fast for any ordinary solar system object. The discovery observations were quickly submitted to the International Astronomical Union's Minor Planet Center, but follow-up observations from both professional and amateur astronomers around the world revealed something extraordinary. This wasn't bound by our sun's gravity at all. Within hours of the initial detection, telescopes across multiple continents were tracking this mysterious visitor, confirming that humanity had discovered another piece of the cosmic puzzle from beyond our solar neighborhood. The object's unusual path through space immediately suggested it originated from outside our solar system, making it only the third confirmed interstellar visitor in human history. Atlas Survey System. Ever wondered how we can monitor threats from space across the entire globe? The Asteroid Terrestrial Impact Last Alert System represents one of humanity's most ambitious skywatching projects. This network consists of 4 50-centimeter telescopes strategically positioned around the world in locations including Hawaii, Chile, and South Africa. Each telescope boasts an impressive 7.4-degree field of view, about 15 times the diameter of the full moon, allowing them to scan vast areas of sky in single exposures. The system operates with military precision. Each telescope surveys 1/4 of the observable sky 4 times per night at approximately 15-minute intervals. With 110 megapixel CCD cameras, these robotic sentinels can detect objects as faint as magnitude 19, while automatically tracking moving objects across multiple observations. The Chilean facility that discovered 3I Atlas represents the cutting edge of this technology, capable of processing thousands of astronomical images nightly, while automatically flagging potential threats or unusual visitors. This automated detection system has revolutionized our ability to spot cosmic wanderers before they disappear back into the darkness of interstellar space. The network's sophisticated algorithms can distinguish between asteroids, comets, and potentially dangerous objects within minutes of detection, providing crucial early warning capabilities for planetary defense. Object classification and naming. Have you ever witnessed the moment when a mysterious space object transforms from unknown to historically significant? The journey from A11PL3Z to 3I Atlas tells a fascinating story of modern astronomical detective work. Initially, when the object was first spotted on July 1, 2025, it received the temporary designation A11PL3Z, following standard protocols for newly discovered moving objects. Within just 24 hours, observations on July 2, 2025 by multiple observatories including the Canada-France-Hawaii Telescope and Lowell Discovery Telescope revealed something crucial: a faint coma and 3 arcsecond tail. This discovery immediately elevated the object's status from potential asteroid to confirmed comet, fundamentally changing how scientists would study and classify it. The Minor Planet Center then bestowed upon it the prestigious designation 3Y Atlas, where 3I signifies it as the third confirmed interstellar object ever discovered by humanity. Simultaneously, it received the official cometary designation C/2025N1 according to international naming conventions. By the time this announcement was made, astronomers had already collected 122 observations from 31 different observatories worldwide, demonstrating the unprecedented global coordination required to track these elusive cosmic visitors. The rapid classification process highlighted how modern astronomy has evolved to quickly identify and study these rare interstellar objects before they vanish forever. Orbital characteristics. So what does it actually take for an object to completely escape the gravitational grip of our solar system forever? Well, 3I/Atlas possesses orbital characteristics that are honestly nothing short of extraordinary, placing it among the most extreme objects ever studied. Racing through space with a hyperbolic excess velocity of 58 kilometers per second relative to the Sun, this interstellar visitor moves significantly faster than both previous interstellar objects, 1I/Oumuamua at 26 kilometers per second and 2I/Borisov at 32 kilometers per second. Its trajectory follows an extremely hyperbolic orbit, with an orbital eccentricity of 6.141, which is the highest ever recorded for any confirmed interstellar object in human history. This extreme eccentricity makes the comet's path appear almost perfectly straight rather than curved, at least when you look at it from our solar system. 3. I/Atlas will reach its closest approach to the Sun on October 29, 2025, passing at a safe distance of 1.36 astronomical units, so that's roughly 203 million kilometers away. Thankfully, Earth remains completely safe during this encounter, as the comet will never approach closer than 1.8 AU to our planet. After its solar encounter, this ancient visitor will continue its relentless journey back into the vast emptiness of interstellar space, carrying with it the gravitational signature of its dramatic passage through our solar system for, well, billions of years to come. Physical properties. So, how do you measure something that's surrounded by a cloud of gas and dust, millions of kilometers away, out there in the depths of space? Determining 3I/Atlas's physical characteristics actually presents some pretty unique challenges, mostly due to its active cometary nature, and all the interference from its surrounding coma. Early estimates suggest the nucleus diameter ranges somewhere between 0.8 to 11 kilometers, though astronomers tend to favor the lower end of this range based on brightness measurements and activity levels. The Gran Telescopio Canarias made a crucial breakthrough between July 2nd and 5th, 2025, determining that the nucleus rotates with a period of 16.79 hours. The brightness variations are only 0.2 magnitudes, which actually suggests a relatively round shape. Color observations using the Palomar 200-inch telescope on July 3, 2025, revealed some fascinating details about its surface composition: a GR color index of 0.43 magnitudes, RI of 0.16 magnitudes, and a spectral slope of about 1.3% per 100 nanometers. The comet's absolute magnitude measures approximately 12, which corresponds to a nuclear radius of roughly 10 kilometers, assuming typical asteroid-like albedo values. These measurements, though, become increasingly difficult as the comet develops a more extensive coma, making it really challenging to distinguish the solid nucleus from all the surrounding ejected material that creates that classic fuzzy appearance. Advanced imaging techniques and computer modeling are being used to separate the nucleus signal from the contaminating coma light. Comet activity features. So what makes 3I/Atlas behave more like 2I/Borisov than the mysterious and inactive 1I/Oumuamua? Unlike the first interstellar visitor, which showed no cometary features whatsoever during its passage, 3I/Atlas actually displays clear signs of vigorous activity even while it's 4.5 astronomical units from the Sun, much farther out than most solar system comets start showing activity. The comet exhibits a distinct fuzzy appearance in telescope images, which indicates a well-developed coma, a cloud of gas and icy dust particles ejected from the nucleus surface as solar radiation heats up volatile materials. Spectroscopic observations by Gemini South and the NASA Infrared Telescope Facility on July 5th and 14th, 2025, confirmed that the coma contains water ice and silicate grains with radii of about 10 micrometers. The dust cross-section within 10,000 kilometers of the comet measures 230 square kilometers, assuming an albedo of 0.10. As solar heating intensifies the sublimation process during its approach, micrometer to millimeter scale particles are ejected at speeds ranging from 0.01 to 1 meter per second, resulting in a dust mass loss rate of 0.1 to 1.0 kilograms per second. This activity level suggests the presence of highly volatile ices that have remained frozen for billions of years, potentially preserving ancient chemical signatures from its original star system. Amateur contributions. So, how did citizen scientists around the world help unlock the secrets of this remarkable interstellar visitor? Well, the discovery and characterization of 3I/Atlas marked a historic milestone for amateur astronomy communities worldwide. It really shows how modern technology has, democratized space exploration in ways we couldn't have imagined a few decades ago. Let me tell you about Vamshi Kesareddy, a dedicated citizen astronomer. On July 4th, 2025, he achieved something pretty remarkable by successfully capturing 3I/Atlas using a unistellar telescope and measuring its brightness at 17.8 magnitude. This observation potentially represents the faintest object ever detected by the unistellar network, which just goes to show the incredible capabilities of modern citizen science equipment and automated imaging systems. And there's more. amateur astronomer Sam Dean made some crucial contributions too, by meticulously identifying additional ATLAS prediscovery observations from June 5th to the 25th, 2025. This extended the observational arc and really improved the orbital calculations. Meanwhile, the Las Cumbres Observatory Network, using 0.36-meter telescopes at Haleakala and the 2.0-meter Falks Telescope North, provided essential photometric data. They showed light curve variations of less than 0.2 magnitudes over a 29-hour time span. All these amateur contributions proved absolutely invaluable, as 3I ATLAS traveled through star-crowded fields near the galactic center. In fact, professional surveys might have missed it entirely because the dense stellar background creates confusion in automated detection systems. So it's clear that the passion and dedication of citizen scientists are, honestly, making a real difference in our understanding of the cosmos. Surface composition. So, what can the colors and reflected light from 3I/ATLAS actually tell us about its ancient origins in a distant star system? Spectroscopic analysis, reveals some fascinating details about this interstellar wanderer's composition and the environment where it formed billions of years ago. Observations using the Very Large Telescope on July 4th and 5th, 2025, didn't detect clear signs of hydroxides and cyanides gases in the coma, placing upper limits on outgassing rates of about 8.2 times 10 to the 26th molecules per second, and 5.6 times 10 to the 23rd molecules per second, respectively. However, the comet's red spectral characteristics did show up in multiple independent observations, with a spectral slope measuring 18 plus or minus 4% per 1,000 angstroms, making it significantly redder than most solar system comets we've studied. The water ice and silicate mineral composition, detected through infrared spectroscopy, suggests a pretty typical cometary makeup, but the comet's distance from the sun during those early observations meant that many volatile compounds stayed frozen solid. Scientists predict that carbon dioxide and carbon monoxide ices are likely present within 3I/ATLAS, though these substances haven't yet been detected as gas emissions. Future observations by the James Webb Space Telescope will provide more detailed compositional analysis as the comet gets closer to the sun and becomes more active, potentially revealing the pristine chemistry preserved from its formation environment. Interstellar object density. So just how common are these cosmic visitors from beyond our solar system wandering through the galaxy? The discovery of 3I/ATLAS actually provides crucial insights into the population density of interstellar objects that have been ejected from their parent star systems and now drift through the vast spaces between stars. Based on 3I/ATLAS's characteristics and the circumstances of its detection, astronomers calculate a spatial number density of approximately 1 in 1,000 objects per cubic astronomical unit for objects with radii greater than or equal to that of 3I/ATLAS. This means that within a cube of space measuring 1 astronomical unit on each side, we might expect to find about 1 object of 3I/ATLAS's size or larger every 1,000 such volumes throughout local interstellar space. The rapid succession of interstellar discoveries, first one I/Oumuamua in October 2017, then 2I/Borisov in August 2019, and now 3I/ATLAS in July 2025, suggests these objects may be far more common than previously thought by theoretical models. Statistical models now indicate that millions of such objects likely pass through the outer solar system undetected each year, basically invisible to our current detection capabilities. The ATLAS network's improved sensitivity and comprehensive sky coverage now mean we're finally reaching the detection threshold necessary to regularly spot these ancient wanderers from distant stellar neighborhoods. Origins and age speculation. Could 3I/ATLAS actually be older than our entire solar system, carrying materials from the early galaxy? The comet's extreme velocity and unusual trajectory provide some tantalizing clues about its ancient origins in a very different cosmic environment. Moving at 58 kilometers per second relative to the Sun, 3I/ATLAS likely originated from the Milky Way's thick disk, which is a region populated by older stellar populations that formed when the galaxy was younger and chemically different. This suggests the comet could be at least 7 billion years old, which is significantly older than our 4.6 billion-year-old solar system, and potentially containing pristine materials from the early galaxy. The thick disk connection indicates 3I/Atlas formed around low metallicity stars that existed when heavy elements were much rarer throughout the cosmos. Its high velocity suggests it was violently ejected from its parent system through dramatic gravitational interactions, possibly involving massive planetary bodies or close stellar encounters that flung it into interstellar space. The comet's water-rich composition and early activity patterns support theories that it formed in the outer regions of an ancient planetary system, where volatile ices could condense and survive for billions of years in the cold depths of space. This cosmic time capsule really offers an unprecedented opportunity to study materials that predate our solar system's formation. As 3I/Atlas continues its epic journey toward the Sun, reaching closest approach on October 29, 2025, it carries with it secrets from the ancient galaxy that we're only beginning to unlock. This remarkable visitor reminds us that space is filled with wandering worlds, each telling a unique story of cosmic evolution. For more mind-blowing space discoveries that challenge everything we thought we knew about our universe, make sure to like, share, and subscribe to Space Facts, where the cosmos reveals its greatest mysteries. Could an object speeding through our solar system from the void between the stars actually be an alien spacecraft? On July 1, 2025, a mysterious visitor designated 3Y Atlas was discovered, sparking a fierce debate. Was it a natural comet, or the first definitive proof of extraterrestrial technology? One prominent Harvard scientist fanned the flames of speculation, while NASA pushed back with hard data. What followed was a clash between radical ideas and rigorous evidence. Let's explore this together. The Atlas discovery in Chile. So how do we even spot these interstellar travelers in the first place? It starts with a constant, vigilant watch of the night sky. The story of 3I Atlas began on July 1, 2025, at an observatory in Chile. There, a robotic survey system named ATLAS, which stands for Asteroid Terrestrial Impact Last Alert System, detected a faint object at an apparent magnitude of 20, making it about 2.5 million times fainter than the faintest star visible to the naked eye. Led by principal investigator John Tonry, the ATLAS system is a NASA-funded project developed by the University of Hawaii, using its twin half-meter telescopes to scan the entire visible sky every 24 hours. When astronomers calculated the object's trajectory, they saw it was following a sharply hyperbolic path with an orbital eccentricity greater than 1, a definitive sign it wasn't gravitationally bound to our sun. Its orbit was an open curve, meaning it came from deep space and was destined to return there. The object was named 3I Atlas, with the 3I marking it as the third interstellar object ever discovered. It was racing through our system at a stunning hyperbolic excess velocity of 35 kilometers per second, a truly exceptional catch and a prime target for immediate scientific study. Avi Loeb's controversial hypothesis. But what if a new discovery doesn't fit neatly into our existing boxes? This is where science can get heated. Enter Avi Loeb, a Harvard astrophysicist and the head of the Galileo Project, an initiative dedicated to searching for evidence of extraterrestrial technology. Having previously sparked debate by suggesting the first interstellar object, Oumuamua, could be artificial due to its observed non-gravitational acceleration, Loeb turned his attention to 3I Atlas. He pointed to its early lack of a visible tail and what he described as a trajectory that might eventually show subtle deviations not caused by gravity. In a paper released on the ArXiv preprint server, a common practice for rapidly disseminating new ideas, he proposed his radical hypothesis. If the object continued to show no outgassing, it might be a technological artifact. He even raised the hypothetical possibility of malign intent, suggesting it could use the sun for a gravitational slingshot to alter its course towards an undisclosed target. Loeb was careful to frame this as an intellectual exercise, admitting a natural comet was the simpler explanation. Still, the mere mention of alien technology from a scientist of his stature was enough to ignite a global media firestorm and put serious pressure on the astronomical community to respond. Media sensation versus scientific method. Here's the thing about alien theories. They travel faster than light speed in the media. Avi Loeb's hypothesis for 3I Atlas was sensational. Headlines around the world, from online blogs to major news networks, quickly latched onto the most dramatic elements of his proposal, the possibility of an alien craft with potentially hostile intentions. This created a fascinating public spectacle but also highlighted a fundamental tension in how science works. The scientific method is a slow, methodical process that can take months or even years of observation and peer review before any conclusion is reached. In stark contrast, the news cycle operates in mere hours. The global conversation was suddenly centered on a dramatic, unproven idea while the painstaking work of collecting hard data was just beginning. This put NASA in the position of having to respond not just to a scientific hypothesis, but to a worldwide media event fueled by one of the most compelling questions in human history. It was a classic case of exciting speculation, published on a preprint server before peer review, getting a massive head start on the deliberate, evidence-based investigation. This gap between speculation and verification is where misinformation can thrive. NASA's comprehensive investigation. When a claim is that big, you really need the world's premier space agency to weigh in. So how did NASA approach the mystery of 3I Atlas? Well, they didn't rely on just a single instrument. Instead, they launched a coordinated, multifaceted observation campaign, allocating dozens of hours of precious observation time on their flagship observatories. This involved the Hubble Space Telescope, using its Wide-Field Camera 3 to capture incredibly detailed visible light images, and the James Webb Space Telescope, using its NIRSPEC instrument to analyze the object's infrared light for chemical signatures. A network of powerful ground-based observatories, like the Keck Observatory in Hawaii with its massive 10-meter twin telescopes, also joined the effort to track it continuously. This wasn't just about taking pictures. The goal was a deep analysis under the guidance of experts like Dr. Karen Meech, a leading astrobiologist renowned for her work on distant comets. This comprehensive approach was designed to replace speculation with an overwhelming body of evidence. NASA's mission was clear: to determine, with the highest possible degree of scientific certainty, the true nature of this interstellar visitor and let the data tell the real story. Comet behavior confirmed. So what does a comet actually do when it gets close to the Sun? The answer to that question was the key to solving the 3I Atlas mystery. As the object continued its journey inward, NASA's array of telescopes watched its every move. The findings were unambiguous. By late July 2025, as it crossed inside the orbit of Mars, 3I Atlas started to behave exactly like a comet. It developed a glowing coma, a fuzzy atmosphere of gas and dust, that eventually grew to over 100,000 kilometers in diameter. Soon after, it began to sprout a tail of dust and gas stretching for millions of kilometers, pushed away from the nucleus by the solar wind. Dr. Lori Glaze, director of NASA's Planetary Science Division, summarized the findings clearly, stating that the object was exhibiting all the classic signs of a comet, reacting to the sun's energy. Its initial lack of a tail was simply because it was too far from the sun for its ices to sublimate. The final verdict from the data was it looks like a comet, and it acts like a comet, so there was no need for an exotic, artificial explanation when a natural one fit the observations perfectly. Chemical composition analysis. Here's what really matters. You can learn a lot about something by the light it gives off. Using a technique called spectroscopy, a team of astrochemists led by a figure like Dr. Stephanie Malam from NASA's Goddard Space Flight Center analyzed the chemical makeup of 3I Atlas. This process is like a cosmic fingerprint analysis, where light from the comet's coma is split into a spectrum, revealing the distinct signatures of the molecules within it. The analysis confirmed the presence of water ice, but it was the other volatiles that were truly telling. They found a carbon dioxide to water ratio of 0.6, nearly double the average for comets in our solar system. The data from JWST also revealed significant amounts of carbon monoxide and traces of diatomic carbon, the molecule responsible for giving many comets their distinctive green glow. Far from being evidence of artificial design, these unique chemical traits told a story of its origins. The high CO2 content suggested that 3I Atlas formed in a brutally cold region of its home star system, much farther from its parent star than where our own comets were born. It was a pristine sample from a truly alien yet completely natural environment. Trajectory and safety assessment. With all the talk of alien technology and malign intent, a critical question had to be answered. Was this object a threat to Earth? The bottom line is a definitive no. NASA's Jet Propulsion Laboratory, or JPL, used the global observation data to refine the comet's trajectory with pinpoint accuracy. Their calculations, made public through the Center for Near-Earth Object Studies, showed its closest approach to Earth would be a distant 1.8 astronomical units, which is roughly 170 million miles. There was never any risk of impact. The comet's orbit was also highly inclined at 60 degrees relative to the ecliptic plane, the flat disk where the planets orbit, meaning it was passing high above the main traffic of the solar system. Its perihelion, or closest approach to the Sun, was calculated to be a safe 1.5 AU, well outside of Earth's orbit. NASA's Planetary Defense Coordination Office was therefore able to declare with certainty that this object posed zero threat. This precise tracking dismantled any notion that the comet could be a danger, allowing everyone to focus on the science. Natural anomalies in cometary physics. But what about the unusual traits that sparked the controversy in the first place? It's important to remember that in astronomy, unusual does not automatically mean unnatural or artificial. Comets, even the ones from our own solar system, are, notoriously unpredictable. To provide some context, NASA pointed to historical examples like Comet 17P Holmes. Back in 2007, that comet suddenly brightened by a factor of nearly 1 million in less than 48 hours, totally shocking astronomers as it briefly became the largest object in the solar system by volume. This was a completely natural outburst, not an artificial maneuver. Cometary physicists like Dr. Michael Kelly from the University of Maryland explain that these events happen when sunlight penetrates a comet's crust and hits a pocket of supervolatile ice, like frozen carbon monoxide, causing it to flash sublimate and release enormous amounts of gas and dust. These anomalies are not evidence of intelligent control, they are actually a normal and expected part of cometary physics. The strange initial behavior of 3Y Atlas wasn't a sign of technology, it was a sign that it was a dynamic natural object. Scientific value of interstellar visitors. So, if it's not an alien ship, why is 3Y Atlas still such a big deal? Well, because its scientific value is immense. Every interstellar object that passes through our solar system is like a pristine time capsule delivered from another star. These objects carry the unique chemical and physical fingerprints of the planetary nursery where they were born. The high concentration of carbon dioxide in 3Y Atlas tells us it likely formed in an incredibly cold, distant region of its home system. Some studies even suggest it could have originated in the Milky Way's thick disk, a population of older stars, making the comet potentially over 7 billion years old, actually predating the formation of our own sun and planets. Scientists could test this hypothesis by analyzing its isotopic ratios, for instance, the ratio of carbon-12 to carbon-13, and comparing it to other stellar populations. That makes it more than just a passing rock. It's a preserved fragment from the dawn of another world, providing invaluable data for our models of galactic chemical evolution. Comparing 3 interstellar objects. Let me explain why having more than one of these visitors is so crucial. By comparing them, we can start to build a bigger picture of the galaxy. 3. I-Atlas was the third interstellar object detected, and it's fascinating how different all 3 have been. The first, 1E Oumuamua, was highly anomalous, rocky, appearing to have an extreme 10:1 aspect ratio, and showing no visible coma, which is what led Avi Loeb to his original theory. The second, 2I Borisov, discovered by amateur astronomer Gennady Borisov, was almost the opposite. It looked and behaved very much like a standard long-period comet from our own Oort cloud, with a chemical composition, specifically a carbon monoxide to water ratio of about 0.3, that was remarkably familiar. 3I Atlas falls somewhere in the middle. It clearly behaves like a comet, but its distinct chemical ratios and light-scattering properties make it stand out as unique. This diversity is exactly what astronomers hope to find. It allows them to test whether the processes that shaped our home system are typical, or if we are, an outlier. In the end, Comet 3. I-Atlas wasn't an alien messenger, but it did bring an incredible message. It wasn't science fiction, but it delivered profound science. It carried the chemical secrets of its birthplace, a star system far from our own, giving us a rare glimpse into the diversity of worlds forming across our galaxy. The real story isn't about a manufactured object, but about the natural wonder of the universe and our growing ability to study it. If you want more deep dives into the biggest discoveries from space, Don't forget to like, subscribe, and hit the bell icon. The universe always has another surprise waiting for us. Thanks for watching Space Facts.